Today, I'm analyzing Felix Baumgartner's human rocket jump, where he fell from around 120 feet and broke the sound barrier. My goal is to model his motion using physics, especially gravity and air resistance, and explain how he was able to reach supersonic speeds. Felix started his jump in the stratosphere, where the air is extremely thin, and as he fell, he accelerated to over the speed of sound. The key question is how physics explains this, and to answer that, we will need to understand the forces acting on him and how the atmosphere changes as he falls down back to Earth. The two main forces are gravity pulling him down and air resistance resisting this and thus pushing upwards in the opposite direction. For air resistance, the best model here is quadratic drag, meaning drag depends on velocity squared. This is appropriate because Felix is moving very fast, close to the speeding sound, so linear drag wouldn't be accurate. A key detail is that drag also depends on air density, which changes with altitude. So the most realistic model is quadratic drag with changing air density, which allows for us to better predict its motion. One of the most important factors is that air density changes with altitude. At the start of the jump, the air is very thin, so drag is small and Felix accelerates quickly under gravity. However, as he falls lower, the air gets denser, which increases drag and slows his acceleration. If we ignored this and assumed constant density, we would underestimate his speed at the start of his descent. So including this changing density is crucial for making accurate predictions. To determine if Felix breaks the sound barrier, we also need to model the speed of sound. The speed of sound depends on temperature and not just a fixed number. At high altitudes, the air is much cooler, which lowers the speed of sound, thus actually making it easier for Felix to go supersonic. So instead of comparing his speed to the usual value at ground level, we will use a lower value that matches the cold upper atmosphere. When asked why Felix was able to break the sound barrier, it was mainly because of his starting altitude, obviously. Jumping from higher up means that lower air density, which air density is proportional to drag, allows more acceleration before resistance becomes significant. If you jump from a lower height, even if he had time to get to his equal to where drag is equal to gravity, he still would have had a tougher time breaking the sound barrier because of that higher resistance from the denser air. So altitude does play a very crucial role in whether breaking the sound barrier is even possible. The physics model predicts that Felix accelerates quickly at the start due to low drag, reaches his maximum speed while still in relatively thin air, and then slows down as he enters denser parts of the atmosphere, which matches the real observations from the jump, showing that the model does a good job describing what actually happens. In conclusion, Felix Baumgartner's jump can be explained using gravity, quadratic air resistance, and changing atmospheric conditions. The combination of low air density and lower speed of sound at high altitude made it possible for him to become a human rocket. This shows how physics models can accurately explain even extreme real-world situations like the stuff that Red Bull is doing. Thank you very much. I am Thomas.